Welcome everybody. So this is the next exercise of the first chapter, exercise 1.2. So the question says, state whether the following real number as rational numbers or irrational numbers. So we have checked a set of number as rational number or irrational number. So we have a note saying that if an integer is within the square root, to check whether that number is rational number or irrational, we have to find out whether the integer is square number or not. If the integer is square number, then it is a rational number. If it is not a square number, then it is an irrational number. So within a square root, if we have a number, we have to check whether that number is a square number or not. If it is a square number, then it is a rational number. If it is not a square number, then it is a irrational number. So what is a square number? A square number is a number like this, a number like 1. 1 into 1 is 1. 4, 2 into 2 is 4. We could make square from those numbers. 2 into 2 is 4, 3 into 3 is 9. 9 is a square number. 16 is a square number. 5 into 5, 25 is a square number. So 5 to the power 2 is 25. So if 25 comes inside a square root, it would be 5. If 16 comes inside a square root, 16 to the power half, so it is 4. 9 comes inside a square root, it would be 3. So if a square number comes inside a square root, we get a rational number. So first question is root 2. 2 is not a square number, so it's not a rational number, it's an irrational number. Next we have 25. 25 is a square number, so it's a rational number. Next we have 6. 6 is not a square number, therefore it's an irrational number. Going to the next part, D. 11. 11 is not a square number, so it's an irrational number. Next we have 6.52. So it's just a number. It's just a number, so it would be a rational number. It's a finite decimal. It's having a finite decimal, so it's a rational number. Next question of exercise 1.2 says, determine whether each of the following statement is true or false. So we have to check whether the statements are true or false. First, let's see the first statement. Before seeing the statement, we'll see a small note about the numbers. Real number could be divided into two, rational number and irrational number. Under rational number, we get finite decimal and recurring decimal. Under irrational number, we get infinite decimal. So the decimal doesn't stop in recurring decimal and infinite decimal, but recurring decimal has some pattern. A set of number, the set of same number will be recurring in recurring decimal. Infinite decimal will not have any pattern and they will not show any recurring numbers. Only in recurring decimal we will get that recurring. So this is how the real number is divided, categorized, and next we have how decimals are categorized. Decimal is categorized into finite decimal and infinite decimal. Under finite decimal we get the rational number. All the rational number will have finite decimal. Under infinite decimal we are getting recurring decimal and also irrational decimal. Irrational decimal in the sense all the irrational number will have irrational decimal. So square root of 3, something like that, will have a irrational decimal. So it will come under infinite decimal. This is how decimal is divided and categorized. Previously we saw the how real number is categorized. So let's see the statement. So statements will be something related to that charts. Any real number is a finite decimal or an infinite decimal. Any real number is a finite decimal or infinite decimal. Yes, we saw that real number could be divided into two parts. real number could be divided into two parts. Was it finite decimal and infinite decimal? It was rational number and irrational number. So rational number had finite decimal, and under infinite decimal we see recurring, and so all the decimal will come under finite and infinite. So it's true. All real number are either of this type. So we can confirm it from the previous chart. Before going to the B question, let's see the C question, which is somewhat similar to A. So in the C question they are saying any real number is a recurring decimal or an infinite decimal. So we could say false, because we agreed with the previous statement. Any real number is a finite decimal or an infinite decimal. Here they are saying any real number is a recurring decimal or an infinite decimal. So what about the finite decimal? Recurring decimal will come under infinite decimal as per the chart we saw. So recurring decimal will come under the infinite decimal, and infinite numbers also will come under infinite decimal. So finite decimal is not in there, not coming under this statement. So this statement is false, because A statement is true. Finite decimal and infinite decimal will be true. So this is false. We could see the reason in the A statement. Any real number is a finite decimal or an infinite decimal. Next we'll see the question B. There can be rational numbers with infinite decimal representation. So it's true, there can be rational numbers with infinite decimal representation, because recurring decimal, rational numbers show recurring decimal. So recurring decimal will come under infinite decimal representation. Some rational number could be written as recurring decimal. Recurring decimal comes under infinite decimal representation. So the statement is true. So the last question D says 0.01011011011110 is a rational number. So we see there is a pattern in this, but we see there is no recurring. There is no same number recurring, or there is no a set of number recurring. Here we see a pattern, but there are no recurring numbers. 0 1, we could 0 1 and 0 1, again we are getting a 1. So there is no recurring in here, just a pattern. So the statement is false. This decimal should be a recurring or finite decimal to be a rational number. That is the first point. To be a rational number, that should have a recurring decimal, or it should be a rational number with finite decimal. This is not a finite decimal. For this decimal to be a recurring decimal, a number or number set should be recurring. A number or set of number should be recurring, but there is no recurring here. Although there is a pattern in this number, there is no recurring. So there is a pattern, but there is no recurring. So we understood this.